All right. Well, we're going to get started. Appreciate everyone coming. So look, ephemeral environments, why and how. We're going to kind of talk about this paradigm that is starting to get a lot of momentum, why that makes sense, and how you can do it. So let's get started. Okay. All right. So, hi, I'm Benjie. I am the CEO and co-founder of Shipyard. I've been building DevOps pipelines with my co-founder, Peter, for a very long time. Essentially, we were kind of high-priced Kubernetes consultants. And the initial version of Shipyard was actually built kind of as an exoskeleton for us to make our lives easier, because we kept kind of building the same thing over and over again for every organization. We're very fortunate to be joined by Ashley, and she's going to be moderating a Q&A throughout, or at the end rather. So please feel free to ask questions in the chat itself. And one thing I'm going to do right now, it's a little foreshadowing, is I'm going to activate this poll. I hope it works. And it's just, let me know what your favorite color is. There's a reason for this, I promise. So I'm just going to do that real quick. And you guys can all vote, and we'll leave that open for a while. Okay, so let's get moving. All right, so the first thing is, what is an ephemeral environment? The way that we define it over at Shipyard is it's a short-lived, fully encapsulated deployment of an application. So this means that your application, it's fully independent. It has the code, it has all your services, it has the state. So it has all these really important things that you need to be conscientious of. And also, more important, and really challengingly, it also has third-party dependencies. So there's no dependency outside of it that if it breaks or you don't have it, you can do everything you can do with production with ephemeral environment. That's kind of the idea here. But before we kind of dive too far into that, let's go for a little history lesson. So a lot has happened in the last 2 decades of computing. And I think the big turning point for all of this was around 2004, when Intel added hardware-assisted virtualization for x86. What that means is that prior to that moment, you had software virtualization happening. So kind of the host operating system was interpreting any type of operating system on top of that. Very slow, a lot of latency there. Intel adds the ability for myself to have, let's say I'm running Windows, and I have, which I haven't done for years, but I'm running Windows and I want to run Linux in a virtual machine. That virtual machine is actually talking directly to my CPU, directly to my RAM, directly to my hard disk. So there's no latency from the operating system side. So that's where virtual machines come from. That's where the cloud comes from. There's a few problems with that. The biggest one being that they're kind of slow, because you have to load the entire operating system and your application, all that stuff. So kind of unbeknownst to us, I think in 2007 or so, C groups gets added into the main line of the Linux kernel. And this is kind of the first time that containers are really something that are used heavily. Google's behind this for the most part. And what C groups do is modern day containers. They basically allow you to just have the application code and then share the operating system resources. So that's really important. We don't really notice it as a community outside of maybe the bigger technology organizations, but it happens. Also under the hood, now you have all these applications, all these containers. Who's going to make sure that they work? Who's going to make sure that when they die, they get spun up or they spun down and all that stuff? So that's called orchestration and scheduling. And Google creates something called Borg that does that internally for them. Then kind of fast forward, and Google's doing this. Google's a pretty big company. They've come to success using commodity hardware and all this amazing software that allows for this elasticity of your infrastructure. And so then in 2013, .cloud comes around, and they basically give us an API to C groups and to containers itself. That's where Docker comes from. There's one more missing piece. In 2015, Google creates Kubernetes or releases Kubernetes on the world. And that is basically an open source version of Borg, taking their best practices and stuff they learned from pretty hardcore scheduling and orchestration and bringing it in there. Okay, So now we have the technology. That brings us to today. We've got Docker, we've got Kubernetes, we've got all this really cool open source stuff, some closed source stuff. But how can we use that technology to make us faster? Because frankly, it can be overwhelming. So going back a second, we're going to talk about continuous application development. So this is kind of like the agile method or whatever. It's approximation of it. But basically, a product gets defined. Product defines a feature. An engineering manager, a PM, they plan and assign it. Developers work on those features. Reviews happen. QA happens. End-to-end testing happens, hopefully. And then eventually it gets deployed to prod. And if we're being honest, there's a bit of praying that happens on every prod deploy. I think that's ubiquitous. So then comes the DevOps team. The people that aren't praying, well, they're praying probably the most, but they're also the ones trying to make this stuff work. So the responsibility of DevOps team is to actually package, build, and deploy the application that all these other team members are working on. They're creating and maintaining all this infrastructure, how you turn these things on, how you turn them off. And ultimately, they're responsible for all the environments that you need to build, test, and run. So here's a typical long-lived environment workflow that we've seen a bunch of. So you kind of got your local environment. As a developer, I'm writing code. It's great. I do that. Then I push my code. It gets onto development. Typically, there's a lot of UAT and some user testing there. Eventually, it gets pushed onto staging. And if we're being honest with each other, that's probably where most of the testing happens. And you've got amazing tools in your CI/CD pipeline that runs all kinds of stuff. And then eventually, if it passes all that stuff, it gets onto production. So what happens when a dev pushes something and it breaks one of these environments? Well, first off, we have to keep in mind that environments that aren't production, they're supposed to be fragile. Like you're working, you're iterating, you're going to break things. The problem is that when you break something, it cascades quickly to the rest of your entire team, and you start blocking people. Your review process grinds to a halt, all kinds of problems. And then in some instances, production actually goes down. More importantly, production goes down and you can't actually fix production because these other environments are also broken. So a DevOps person kind of becomes an SRE for every environment. And that's kind of the state of a very typical early stage and sometimes not too early stage companies. This is kind of a pretty typical thing. Credit to firehydrant.io, which is a great SRE tool. We're friends with those people. Inspired very much this graphic. So I just want to give a little credit there. So what's the answer to this? Ephemeral environments. This is the way. I hope Disney doesn't sue us for that one. So ephemeral environments, what are they? They're short-lived, fully encapsulated environments. They give us the ability to understand where the state of an application is at any given time, and you can test all these things. So there we go. So you want to break things, you don't want to block things. So with the ephemeral environment paradigm, and again, this is not a new paradigm. This is something that Fang's been using for years. There's a reason why we don't see broken buttons in Facebook or Google products. There's plenty of other issues that happen, but the product itself is pretty bug-free when it comes out. And the reason is because they adopt the ephemeral environment paradigm, which means that everybody gets as many environments as you want. So QA, dev, product, testing, your CEO, your CTO, whoever it is, everyone gets as many environments as they want, and it's theirs to break. And guess what? If that's happening and I break something, it doesn't affect my coworker or across the dev team, across anything. So now you're able to test production-like environments and find the problems before they get to prod and before they escalate up toward these other environments. It also enables this concept of asynchronous collaboration. So instead of having to like set the meeting up so that we can do a screen share to look at a work in progress feature, as a developer, I can just give a link or give some way to get to this ephemeral environment, and everybody's happy. And then a little foreshadowing for the next Shipyard session is testing before merge. So So obviously you want to have users testing this stuff, but if you start doing really good end-to-end testing, say you're using Cypress or Playwright or Mabel or Selenium, the sooner you can do those tests, the sooner you're going to solve all kinds of problems. And we'll talk about that in a later presentation. All right, so what you're going to do here is, and I hate to say it, but it's true, you're going to shift left with ephemeral environments. So now you have this setup where you have your local development happening, you push a PR, an environment is created. It's great. Everyone's happy. Users get to test, put your automated testing in line there, and you're finding not always all of it, but a huge number of bugs earlier on. It also enables the developer to kind of get feedback earlier. So instead of changing your mental model, working on the next feature, you can get these features in the hands of people earlier, which means that they can give you feedback earlier, stronger, faster, which ultimately leads to faster deployment times. We've seen with some of our customers over at Shipyard that are using ephemeral environments, upwards of 50% more velocity in regards to actually getting things out the door. And then in regards to stability and catching issues, we're seeing around the same number there. So it helps you contain your fires. So now your DevOps people can actually be SREs for things that they're supposed to do, which is basically production. And we can kind of fix our own problems over on the ephemeral environment side of things. So that's pretty cool. And that's really what this is about. It's really about getting as much exposure to in-progress features and things that we think are done or close to done as early as possible so that the key stakeholders can give the feedback and figure out if there's a problem before your end user does. So now your DevOps person can just be focusing on making sure that production isn't on fire. So that's a huge benefit. So, okay, so that's kind of the why. So how? So here's what you need to do. First off, you need to think about your code. What does your application look like? So this is solved a term called GitOps. I'm sure many of you are familiar with it. And that is basically when you push code to your source control, an action happens. So I push my code and something gets built and something gets pushed to a deployment, which is great. And a lot of people are doing that. It gets a little complicated when you start adding the other problems there. So you also have services. You've got databases, you've got caching, you've got messaging queues. You got to make sure that those are encapsulated as well. So when you turn on your environment, your ephemeral environment, you have your code and your services. Now it gets a lot more tricky. You have to worry about state. So that means that from environment to environment, you don't want to have to go back in and click on all the buttons. You want to be able to copy your state across multiple environments, make your state portable. And so that people can test other features, other bugs. Oh, I found this issue over here. Let me reproduce it over there. The next big thing for going ephemeral is third-party dependencies and integrations. If you are, and a lot of us are, we're at Shipyard, we work with GitHub, or we use GitHub for our GitOps stuff. How do we simulate getting those pull request webhooks? Or G Suite's another great example. Now, the more you mock, the more you miss, I like to say. Actually, honestly, I just came up with that, but it sounds good. So the more you mock, the more you miss. And what that means is that you really want your third-party dependencies to be actually encapsulated. So if you're using AWS, there's a great company or a great project called LocalStack that helps you mock. It actually mimics your S3, your RDS, all those different services. But there's a lot of other stuff out there. So you really have to figure out how can I have integrations that work with these sandbox things, but don't actually cause too many problems, and are portable across ephemeral environments. And then, of course, and number one always is security. Who has access to this stuff? You should not have PII in your ephemeral environments, at least the early versions of it. Sometimes you do, you shouldn't. We don't think you should. There are exceptions, but even if you putting aside PII, there's secrets, there's keys. You need to interact with these third-party services. So you have to gate access to this. These are internal environments. These are not necessarily things that you want everybody seeing. And then the last piece of going ephemeral is making sure that these things are on demand. Elastic compute is really cool, but if you just leave it all on, it's not really elastic. It's just costing more money. If you've got 50 ephemeral environments and you've got 50 people using these on a day-to-day basis, they aren't working on it 24/7. And the beautiful thing with Kubernetes and Docker and containerization is that it's fast. So it takes me a little bit of time to turn it on, huge amount of savings. Obviously, there's a legitimate environmental impact that will be helping when everybody goes ephemeral. So there's a little bit of an incentive there, but also just for your own cost control purposes as a DevOps engineer. So that's a lot of stuff. Isn't there a platform that can manage this for me? There is. It's called Shipyard. That's where I work. And so we aim to solve as many of those problems or empower you as a user as much as possible to solve all these issues that we just talked about. So now I am going to jump into a product demo. I'm a little nervous that my screen sharing is going to be messed up, but I'm going to try and do it correctly anyway. So I'm going to stop this one. And then I'm going to screen share this one. I mean, it's been 2 years of Zoom and I still don't know how to use this thing correctly. Great. Okay. So, great. So I'm already logged in to Shipyard over here. And we are going to do a very, very basic, simple demo. And what I'm going to do is I'm going to get it started, and then we're going to kind of talk you through how Shipyard does all the things that it needs to do. So the first thing I'm going to do is I'm going to add an application, and I'm going to do a very simple one. It's a Node backend React frontend application. I'm going to go through, we'll talk about this in a second, but we use Docker Compose in this particular instance to define our application. We'll go back and look at that in a second. There are no environment variables, so I'm just going to go ahead and create the application. So that's going to get started. Now we're going to go back to our poll, and I'm going to try and figure out who won. Okay, hot pink won. So hot pink it is. And what I'm going to do is I'm actually going to make a PR that shows this, the public has spoken. Oops, the public has spoken, and we need to do hot pink. So I'm pretty sure that hot pink is actually a option for CSS, but we'll find out. Webinar demo. Actually, no, I don't want to call this a webinar. This is the Shipyard session 1 demo. All right, and we'll just say hot pink. So I am creating a quick PR that is going to, oh, and you know what? Before I do that, I'm going to go over here and actually show you a little cool functionality of Shipyard itself. And I want to get notifications. A lot of this stuff that we're talking about is integrating with your existing workflow. So I'm going to turn on my GitHub, my PR comments before I create that PR. I'm going to go back over here. We're going to create the PR. And all of a sudden, without having to do anything, just in my normal workflow, Shipyard has picked this up and is going to start building in the background. While we wait for that, I'm going to show you a little bit of how we do this. Now, over at Shipyard, we are extremely opinionated. We have seen a lot of shooting yourself in the foot because of how many options you have. Been doing this for a very long time. We feel like sometimes the biggest problem with all the technology and opportunities we have is actually there's too many options. So what we did early on is we actually used Docker Compose as our application definition. So I'm going to show you what that looks like. This is a very simple example, but we kind of say, we have a saying, or I have a saying, and everyone loves a saying, I like it. I say nay, not another YAML. So our whole goal here is to fit in the existing workflow. So for this instance, we're using Docker Compose as our application definition. The idea is if you get it to work locally, we're going to take care of the rest for you. We do extend slightly. We have different labels, and that's metadata in a Docker Compose file for those of you not familiar. And what that enables us to do is kind of give us a little bit of information about what we need to know. So in this particular instance, we have two services, the backend server and the front-end React client, and we want to route to the React client. So we say, hey, this is the route over here. And that's it. And so that's really simple. Now, there's a much more advanced, there's a lot more advanced stuff. I would love for you guys to check out our docs, check out our sample apps. We'll have links at the end. But the one thing to keep in mind about all of that is that, you know, very complex organizations and applications are currently using Shipyard. And so we're always kind of evolving here. And I will say a little preview, Docker Compose is not going to be the only definition that we use. It is the great one that we use right now. It's accessible, but in the very near roadmap, we will have other things. So don't feel like if you're not using Docker Compose, you're not going to be able to leverage Shipyard's tool. So the demos are ready, but I just want to show you one or two other things. We mentioned security. So it's really important to make sure that certain people have access or don't have access. So for all the environments we generate, there is always a layer of SSO that sits on top of them. And what that means is that we integrate with your GitHub, your G Suite, actually anything that's SAML, and OAuth 2, I believe. And what that does is it gates all these environments. We don't have any environment variables for this particular demo, but we also have a very nice secure way to keep things at rest. And then one other thing just to highlight real quick is when building your applications, a lot of the problem is, hey, where did things break on deployment? I don't know. If we go back to that slide, your environment feature number 1 is on fire. We want to give developers and even in some instances product and QA people the ability and the tools to debug what's going on and figure it out. So we have a pretty cool build details page which goes to the build of all these things, and then obviously we have your run logs. One last thing to highlight, because I love it, is we also have a terminal, because remember what we're doing here is we're actually turning on pretty extensive environments. So we give you the ability by leveraging some great open source projects. And just for the record, all of Shipyard is built on amazing open source, and we contribute when we can, and it's pretty cool. But if you take a look, you actually can see the running pods here for the various services, and you can actually exec in and take a look at logs and whatnot. And again, this is about accessibility for developers and everybody else to figure out what's going on before you bring in your DevOps person. Oftentimes, the DevOps person kind of needs to come in and help a little bit, but ideally, we're empowering developers to kind of solve their own problems a bit. All right, so now let's get back to the whole point. So remember, we had mentioned that we put SSO in front. My GitHub handle has been added. So we have, oh wait, I'm sorry, I think I can't pull this out of, I think I'm sharing just that tab. I hope I didn't mess that up. I'm a little worried right now that you guys can't see all these extra tabs that I'm doing. So I'm gonna do this. I am gonna share, I think you can see everything. I think it's fine. If not, this video will be a little wanky, but okay. So on the left over here, we have the hot pink. It worked great. Everyone's happy. I spoke with the people have spoken. Yeah, and then so on the right over here, we have the black, and not to dox anybody, but Jay, thank you for saying in chat that you can see the tabs. That does make me feel a lot better. So the original version is over on the right over here, and then the pink version, the hot pink version is over here. And then just to close the loop here, we also have direct links to this inside of my GitHub, which I had turned on. And remember, fitting into the workflow is one of the most important things, regardless of using Shipyard or not. If you're trying to implement ephemeral environments, if you have to go search things out, it's not going to make it better. So you need to fit within the workflow. So we also have a Slack integration and a bunch of other stuff. But the whole idea here is I can get to these things directly, debug them directly, and fit within the existing workflow. So I think that's actually most of what I wanted to quickly highlight here. There's a lot of other really cool features that we'll probably be sharing in a future Shipyard session. One question that we get a lot that I'm just gonna jump on top of is we do any external registry, we support it, no problem. And what's another question, just real quick before we jump in there, because I feel like that's just a very common question. So we have our private Docker registries over here. Another thing that I'm not going to touch on, we'll do it in the future, but we also have an API. So if you're running Shipyard environments in a CI/CD process and you want to run your tests against an environment that Shipyard has created, we offer that. And the SSO stuff I showed you before, there's a way that you can use your API key to bypass that. So your CI/CD process doesn't need to do any weird GitHub auth or anything like that. And I'm not even going to dive into this too much, but we had mentioned how it's really important that these environments are actually on demand, which also means that they go up automatically, but they come down automatically as well. And so that's our sleep scheduler. And so we can dive into that later, and happy to talk through that stuff later. So that's the demo. Somehow I actually am on time. I think Ashley's going to be very proud of me. I am going to stop sharing my screen. I am now going to bring in Ashley. And I guess what I'll do is I'll share, I think I have a slide for the Q&A. So we'll do that. And then we're going to go over to Q&A time with Ashley.
Awesome. Thanks, Benji. So we have a couple questions in the chat. The first one is, where are these environments running? Is it through Shipyard's own cloud?
That's a great question. So we are running on AWS and GCP. So we host these environments for you and we manage these environments for you. Yes.
Awesome. Okay. Another one in the chat. I have a multi-container app that I normally deploy to Kubernetes. Will I need to maintain both a compose file and Helm chart for my application?
That's a great question. So as of today, Dockerfile is the application definition. We do have some early stuff for just using Helm charts and actually just raw Kubernetes manifests and probably some customized stuff. You should reach out to us directly and we can maybe get you into a early program to start playing with that. Just to clarify here, still think Docker Compose is a great way to encapsulate this stuff, but there are a lot of customers that have larger applications. And the other thing that you bring up with that question, Ashley, is yeah, like you don't want to be maintaining two things. So if you guys are really good at Kubernetes and all these other things, and you just want to use Shipyard as an environment management platform, we're working on that, and actually would love to talk actually.
All right, next question is, you've shown well-contained stuff. What if you need things like a new AWS account or SQS queues or RDS and the like?
That's a great question. So that's where some of these technology stacks come into play. There's a company, I think I mentioned it earlier, actually called LocalStack. It's a massive 30,000 star GitHub project, and they mock out all the AWS services. So what we've seen is a lot of people putting that into their infrastructure, so that if remember, these are production-like, these aren't exactly production. So you can run LocalStack there. And so that's one way. Now, the other side to this, and this gets into something a little bit more complicated, that we are going to actually be doing a pretty cool blog post. One of our awesome engineers, Angel, is writing up a blog post on this. But we have the capability of having what we call the callback gateway. And so the idea is that you can have a one-to-many relationship with third-party services. So there's a little bit of configuration there, but the idea is that using Shipyard, you can route, let's say you have a single sandbox from G Suite, you can route those requests appropriately to the environment that had made the response to the environment that made the request. So it's kind of a constant vigil, but the idea is that we got to do our best to encapsulate stuff. Now, there are other things you can do in regards to creating dynamically resources that are external if you want to do that type of integration.
Cool. And there was some clarification in the chat that they do use LocalStack for local, but that it doesn't translate well to production. And I think you kind of covered that with the callback gateway stuff.
Yeah.
Okay. Cool. Another question, does Shipyard work for non-HTTP, HTTPS services? For example, is there a way to tunnel to a PostgreSQL container?
Yeah, we have the ability to help with that. So yes.
Okay, and next one is Shipyard compatible with applications that normally run with a service mesh like Istio?
Yes, we are. This is kind of a gray zone where is that question from the same person that had asked about using Helm charts by any chance?
Yes, it is.
Oh, there we go. So yeah. So again, if you're kind of a Kubernetes pro, we want to talk to you. And yes, we would do that. It depends on what the dependencies of the service mesh are, but we bootstrap fully encapsulated Kubernetes clusters, single tenant for each one of our customers. So that should be fine.
And does Shipyard work with any programming language?
Yes. So as long as it's containerized, you can use Shipyard for that. One caveat would be you got to use .NET, the Linux.NET. What is that called? I don't know what it's called, but we don't do Windows Docker. We just do Linux Docker. So .NET Core, sorry. So yes, .NET Core, but that's the one limitation. So not .NET normal.
Got it. Okay, so another question in the chat here is, how can Shipyard help me control my cloud costs?
So we touched on that, but a lot of things, a pattern that we've seen, like pop up a lot is, you turn on an environment, maybe it's not supposed to be a long-lived environment, maybe it is supposed to be a short-lived environment, but it kind of gets forgotten. So we have something called since last visit, which basically says, hey, some time interval since someone visited it. We also have a sleep schedule that you can use optionally that says, oh, you know what, our developers are not typically, or QA people or product people are not typically working from 9 p.m. to 9 a.m. So we'll turn that off. And then of course, the thing to keep in mind is you go to the dashboard and you can turn any of these environments on relatively quickly, within a few minutes, depending on the complexity of your infrastructure. So kind of the maintenance, the automatic turning on, and then obviously underneath that, there's auto scaling and other types of things we do to optimize that as well.
Awesome. And one question that came in, I think you might have touched on this, but if I have multiple repositories, front end, back end, et cetera, can I still use Shipyard? And this is the last question we have in the chat. So if anybody has anything left, any other questions, please drop them in now so we can cover them before we wrap up.
Yeah, that's a great question. And that's a really cool feature that we're really proud of. So what we saw was we kind of designed Shipyard originally for a mono repo. And we kept having people be like, well, we've got our front end repository over here, and we've got our back end repository over here, and we've got our code repository, or our IAC, or infrastructure as code repository over here. How can we combine those? And so we've actually taken a philosophy since then of making multi-repo applications first class. So basically you can add as many repositories as you want. And then there's a model that rebuilds everything. Well, it's optional. And we do some pretty cool caching stuff and try and optimize that. One thing that I don't know if this question came up, and I didn't really talk about it, but there was a Datadog logo at the beginning of the presentation. And I think that's important to highlight. Externally, I think the person that was asking about the service mesh and the Kubernetes YAMLs would probably be interested by this. But basically, we also have integrations with where you can tie out to Datadog, and you can or New Relic or whatever it is, and you could use the services you're using in production from the ephemeral environments. And that's another really important thing to do, is you also want to mimic your ability to respond to incidents. So, hey, is that Datadog integration still working? I hope so, because it's better work on production. That type of stuff is very interesting. But to go back to your extra question, yes, we support multiple repos. We're very proud of it. It's just a click of a button, and then it kind of aggregates it all together for you.
Awesome. One more question did come in. Is Shipyard free to use?
Oh, that's a good question. So we currently offer a 30-day free trial to get started and figure it out, with some limits on the number of what we call dry docks, or think of it as environments for right now. And then, that's kind of the pilot time, and then turn you guys on. So yeah, you can come check it out. Please do. Shipyard.build is our website, and there's a free sign up for a free 30-day trial. And feel free to reach out if for whatever reason you might need to extend that a little bit. I have some people that probably are going to get mad at me for saying that, but feel free to reach out.
Awesome. Okay, it looks like we are, there's no more questions in the chat. So I think we're good to wrap up. I think, Benjie, you had a survey that you wanted to mention to everyone.
Oh, yes. Thank you, Ashley. Okay, so thanks for attending, everybody. Really appreciate you taking the time. I hope it was informative. Remember, ephemeral environments, this is the way. For those of you that watch The Mandalorian, you'll appreciate it. For the rest of you, you guys will think I'm crazy, but that's fine. So look, you can get a hold of us a few ways. I would encourage that if you're serious about trying Shipyard, you check out our Slack link right here. That's a bit.ly that goes to our community Slack. So if you're copying it down, it's a little easier to type. Obviously, we're on Twitter. Check us out there. We have a bunch of sample repositories that kind of give you an idea of kind of the power and capability. And there's some good examples. And for the person that said that they are using LocalStack, I believe, or should use LocalStack, we actually have an example of that in there. The other thing that I really want to highlight here is we actually donated or are contributing a resource called ephemeral.environments.io, which is a website that goes in depth about all the benefits and all the gotchas and a lot of the stuff there. You should check that out. That's open source, community contributed. Please, pull requests welcome. We've had a few already. Quotes welcome. The ephemeral environment movement is a strong word, but I really think that we are at the cusp of this being the paradigm that everyone is expecting. So thank you for checking it out. And Ashley, you mentioned that we have a survey at the end. I never fill out surveys, so it's kind of, I feel bad asking, but it would be great if you could fill out a survey. It's just asking you what you're currently using on the container developer side, and then maybe, and this is honestly the most important thing. So thank you for your questions earlier. What are your priorities? What are the priorities that you have for DevOps, for environments? The more we can understand that, the more we can start to continue to build out our tooling there. So I think that's it. Ashley, anything else, or we got any? I did this quickly. Ashley was very worried I talk a lot, so I'm very proud of getting it done.
I think we're good. I dropped the links into the chat for ephemeral.environments.io and as well as shipyard.build. Thanks everyone for joining.
Thank you.